I can use area models to explain the distributive property. To meet this learning target, we need to know what the distributive property is, and we're also going to focus in on areas of rectangles and how to break them down. Let's start with the distributive property. The distributive property says that 3 times 7 equals 3 times 5 plus 2, where I replace the 7 with 5 plus 2 because 5 plus 2 equals 7. Then I can take that another step and distribute the 3 and the multiplication over the addition. So I do 3 times 5 plus 3 times 2. 3 times 2, 3 times 5. If I add them together, 3 times 5 is 15, and 3 times 2 is 6. Now add it together, you get 21. Anyone who knows their multiplication facts knows that 3 times 7 equals 21. Now let's kind of come back and look at that when we're talking about area of a rectangle. I have a rectangle, 3 feet by 7 feet. And because it's a rectangle, if I draw a line straight down from the top to the bottom and split it up, that line's going to be 3 feet long because I just end up creating 2 separate rectangles. In this case, I kind of have rectangle A and rectangle B with this line drawn. And this line is 3 feet long. This one will be 3 feet long. And I coincidentally did it to split the 7-foot side into a 5-foot piece and a 2-foot piece because 5 plus 2 is 7. So now I can do 3 times 7 equals 21 square feet, get the area, sure. Or I could do 3 times 5, and that would give me the area of just rectangle A. And then I could do 3 times 2 and get just the area of rectangle B. At that point, 3 times 5 is 15, 3 times 2 is 6, 15 plus 6 is 21, so you've done 21 square feet both ways. You still get the total area, even if you draw the line down and break it up. Why might I use this? Well, you use it to help you with facts you don't know. So maybe you know 3 times 7. 3 times 7 is 21, I know that. But I don't know what 6 times 8 is. Let's break it apart. If I draw this line down, I now have 2 rectangles. You can call them A and B. Rectangle A, rectangle B. This rectangle is going to be 6 inches by 5 inches instead of 6 times 8. And this rectangle will be 6 inches by 3. And remember that 5 plus 3 equals 8. So that's why you can kind of replace it, because this is still 8 inches long, but we're looking at it in a 5-inch piece and a 3-inch piece. So now I can come over here and I can do 6 times 5 to get rectangle A. And I have to add that to 6 times 3. And that will give me rectangle B. If I find the 2 products, I add them up, that total will equal the total area of 6 times 8. So 6 times 5, well, 5s are pretty simple. That's going to be 30. And 6 times 3 is 18. I know those 2 facts. 30 plus 18, well, that's 10 more 40. 8 more 48. So I end up with 48 square feet, or square inches. And that means that 6 times 8 equals 48. In this case, we're talking about area, so it'll be in square inches. For this one here, I want you to pause the video, and the rectangle is 7 centimeters times 6. Pause the video and try to figure out the area by breaking it down into 2 partial products and add them together. Alright, now I'm going to go through and solve this. So we're trying to figure out what 7 times 6 is. To do that, I'm going to break the 6 apart into 5 plus 1. So I'm going to do 7 times 5 plus 7 times 1. This all of a sudden became a lot easier to me. I can count by 5s to get 7 times 5. It equals 35. And 7 times 1 is just 7. Anything times 1 is itself. And now I'm just doing 35 plus 7. Okay, 35 plus 7 is going to be 42. So when I come back to the total area, it's going to end up being 42 square centimeters. I can use area models to explain the distributive property. So here's another rectangle. You may know this fact, 4 times 7. You may know, but I want you to break it apart. Draw a line down somewhere and split it up into 2 partial products. Break this down to 2 products added together. So maybe you can break the 7 apart and then just fill in blanks. What times what plus what times what?